Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. So let me first say this. I think anybody who studied chemistry or anyone who worked as a bartender probably has an advantage on a question like this, because this is the kind of thing that you'd be doing at work on a regular basis. And I wonder if the first word that is worth kind of noting to ourselves is the word combined, because that's kind of the first hint that we're looking at some kind of mixture question. And so what I'm looking to find out as I continue to read this question is, what is the property that is being mixed? For example, in the bartender analogy, the property would probably be the percent alcohol. You take this drink that has so-and-so percent alcohol, and you take this other drink that has a different percent alcohol, you mix them together and you get some number in between the two alcohol percentages. If it's a chemist, maybe he or she is combining saline solutions, and one has a 5% salt and the other has a 20% salt. So there, the property would be percent salt. And as I continue to read this question, I see that here in this problem, the property is the percent gravel. And we have two types of gravel, one with a 10% and one with the 2%. And I'm expecting to see that the combined mixture has somewhere in between those two numbers. It has to be, just logically speaking, it has to be somewhere in between 2% and 10%. And indeed, we get to that number a bit later on, and we see that it's 5%. So I think that it's absolutely necessary to take a very long pause here before we keep reading and draw a number line to explore where exactly 5 sits in the context of 10 and 2. Does it sit closer to one side versus the other side? And if so, how much closer as a ratio, right? Is it twice as close? Is it thrice as close? What's the ratio of these distances between the average, the 5% gravel, and the two starting points, the 2% and the 10%. We want to see that visually. I would put the 2% on the left side because that's a smaller number in this property that we're comparing. And the 10% will go here on the right-hand side. Yeah, that's right. So we know that the total weight is X tons, for example. So this is telling us that there's 0.1X tons of gravel. And what's the other 0.9X tons? Not gravel. And JD, you're asking about that part, the not gravel. Is the not gravel here the same as the not gravel here? I don't know. Doesn't matter. All that matters is it's not gravel. Yeah, it could be anything, and it could be different things in the first gravel mixture and the second gravel mixture. And that's okay too. We just don't care. So let's label these distances. So we have a distance of 3 units on this side and 5 units on this side. What I do for the next step is I assess my picture visually to see who is winning. What is there more of? Is there more of the 2% gravel, or is there more of the 10% gravel? And the way to answer that question is to see which side the result is closer to. Because it's like a tug of war. Each side is trying to pull the result as hard as they can to their side. And it looks like the 2% side is winning, because you can see that the average, you can see visually it's closer to the left side. And once I've established that, I'm going to build a 3-way ratio. You know how I love 3-way ratios. And I'm going to start my 3-way ratio with a winner. And I always do it that way because that eliminates the possibility of making careless mistakes. So I'm going to start my 3-way ratio with a winner, which in this case is y. And because I always start with a winner, I know that the bigger number goes on the left. And what are the numbers that are going to go there? those are the numbers that are going to go into this three-way ratio. Bigger number goes with the winner and smaller number goes with the loser, and we have a total of 8 ratio units. A lot of people would just build a two-way ratio. They wouldn't have this third column, and in many GMAT questions, that third column is necessary. In fact, I would bet a lot of money that anyone who picked answer choice A on this question didn't have that third column. So always build a three-way ratio once you have that picture. And start with the winning side. So you have to visually establish who's winning, start with that side, and then you know the bigger number goes there. Because a lot of people get messed up with which number goes with which side. So just visually assess who's winning, put the winner on the left, and put the bigger number on the left. And don't forget that third column for the total. They flip over because the greater your quantity, the closer the average will be to you. And what does that mean for your distance from the average? The closer you are to the average, the shorter your distance from the average. So a short distance from the average actually implies that you're much stronger, that there's a lot more of you. And what we have here in our three-way ratio is quantities, right? This is a three-way ratio describing the quantities. So we can now say things like, there are 5/3 as many tons of the 2% gravel as there is of the 10% gravel. Let me put more titles here. The Y is the 2% gravel and the X is the 10% gravel. These are just this is what I'll call the types of material. There's the 2% gravel and there's 10% gravel. So we could say things like, there must be 5/3 as many tons of 2% gravel as there are of 10% gravel. We could also say something like the total number of tons is 8/5 as much as Y. You could say that as well. There are a lot of different inferences we could take out of that rectangle. And we were actually told that the total number of tons is Z, or Z if you're British English. So let's write it that way, right? Z is 8/5 as much as Y. That's an inference we can make from the red rectangle. Does anyone know why I wanted to make this particular inference? What's my motivation for making that inference? Exactly, I peeked at the statements and I said to myself, hey, with the free info that we received, which by the way, there was a lot of, right? Everything up to my red line here is just free info. The question starts at the word what. The free info that we received implies that these two statements are inferentially equivalent. If you know statement 1, you can infer statement 2 using the free info. And vice versa, if you know statement 2, you can infer statement 1 using the free info. And if you read section 2 of my book, you know that you can now eliminate answer choices A, B, and C without even reading the question itself. And when I say the question itself, I'm just referring to this part. Without even reading that part that I put in a pink box, I can already eliminate A, B, and C just by seeing that the statements imply one another in the context of the free info. So for the reasoning behind eliminating A, B, and C, I refer you to section 2 of my book. We're down to 2 answer choices, D or E. So what do you think? Is each of these statements on its own sufficient in order to find X? Or is it just impossible to find the value of X even if we combine the statements?
It's easy.
It's a D.
Yeah, it's D. If I know statement 1, I use this three-way ratio to find the value of X. And same goes for if I know the statement 2, the value of Z. All right, we can say X is 3/5 of Y for my ratio here. So what's 3/5 of 10? 6. So X is 6 tons. And if I look at these two columns, X is 3/8 of Z. The scale factor is 2. And that's great. You can do it that way as well. I like to do it both ways sometimes just to practice looking at ratio tables both vertically and horizontally. Do you know what I mean by vertically and horizontally? So vertically is when we look at the scale factor, going from the world of ratios to the world of actual numbers in the row below it. Horizontally is what I was doing here, right? Is looking at this and saying, oh, okay, so z is 8/5 as much as y, or it's 8/3 as much as x, or x is 3/8 as much as z, or x is 3/5 as much as y. It's very useful in the GMAT to be able to have that flexibility to look at ratio tables both vertically and horizontally. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.